Today I have a video for you on how to draw a carboxylic acid. I have two examples here. The first one I have is butanoic acid. So I'll take you through the steps of how to draw butanoic acid, the structural diagram, and then the second one I have is another carboxylic acid, which is 3-methyl 4-ethyl hexanoic acid. And I'm going to show you how to draw that compound as well, which will have a few branches on top of the carboxylic acid. Right, let's go for the first one. First one is butanoic acid. Let's look at the name and try to break down the name to identify different components in that name. The ending, if you see here, is OIC acid. That ending is indicating that this is a carboxylic acid. It means we will have an ending of COOH, or you can also write it as C double bonded to the O and single bonded to the OH. This is a carboxyl group, and therefore you have a carboxylic acid. The reason why it is called a carboxyl group is because it has a hydroxyl group here. This is the hydroxyl component, and this is the carbonyl component. So if you have carbonyl and hydroxyl together in the same functional group, it becomes a carboxyl group. All right, perfect. So we have that clarified. We have that C double bonded to the OH. The part before it is AN. It indicates it has single bonds between the carbon, so it's all carbon-carbon single bonds. In other words, it's a alkane derivative. It is coming from an alkane. And the first part, BUT, is telling us that it's but. But means it is made up of 4 carbons in the longest chain or the straight chain. Now, since we have the name broken down, let's try to draw it out. So, 4 carbons, we will have 1, 2, 3, and 4. We have our 4 carbons drawn. Next, what we can do is we can decide to put the carboxyl group on the left hand side or the right hand side. It doesn't really matter. So in this case, let's say I will try it on the left hand side. I have a double bonded to the O and single bonded to the OH. Now, since I have put the carboxyl group on the left hand side, that carbon is carbon 1. So let me switch the pen color and show you, or just label the carbons. This becomes a carbon 1, carbon 2, carbon 3, carbon 4. The numbering will start from the side of the carboxylic acid. The carbon that has the hydroxyl and the carbonyl group will become carbon number 1. That has the highest priority. Now, we have the 4 carbons in the chain, carboxyl group attached. Now, there are no functional groups or additional branches on this molecule. So the last thing that we have to do is add the hydrogens. So the first carbon on the left hand side, carbon number 1, already has 4 bonds. So it has maximized its bonding capacity. No more hydrogens can be added to it. Carbon number 2 has 2 bonds. We can add 2 more hydrogens to it. Carbon number 3 has 2 bonds. We can have 2 more hydrogens added to it. And the carbon number 4 has 1 bond, so we can add 3 more hydrogens to it. And that brings us, or gives us, the structural diagram for butanoic acid. The next one I have is 3-methyl 4-ethyl hexanoic acid. Again, breaking down the name, the ending OIC acid tells us that it is a carboxylic acid, which will have a carbon double bonded to the oxygen and single bonded to the OH group. The AN part before it tells us it's a carbon all single bonds. It's an alkane derivative. And the hex part tells us that we have 6 carbons. Right, and the part before that is the branches. So this is a branch that is attached to the main chain, and this is another branch that is attached to our main carboxylic acid. The methyl is a CH3 branch, and the location of the CH3 branch is position 3, as indicated in the name. And the other one we have 4-ethyl, and in this case ethyl is CH2 CH3, and this is located on the fourth carbon. So now drawing the diagram, let's start with the carboxylic acid. 6 carbons, so we'll draw 6 carbons. 1, 2, 3, 4, 5, 6 carbons. So we have our 6 carbons. I'll switch my pen. There we go. So we have 6 carbons here in the longest chain. I will put my carboxyl group on the right hand side this time. As I said, it doesn't matter which carbon you want to place your double bond, and the double bond to the oxygen and the hydroxyl group. But wherever you place it, that becomes carbon number 1. Next is 2, 3, 4, 5, 6. All right, so we have our 6 carbons, hexanoic acid. Now, the additional features we have and additional branches. On the fourth carbon, we have an ethyl group. So on the fourth, we will put an ethyl group, CH2, CH3. And on the third carbon, we have a methyl group. Third carbon, CH3. Right, no other branches. On the molecule, I will fill the molecule with hydrogens. So first carbon already has 4 bonds, no more capacity for hydrogens. Second one, I can place 2 hydrogens. Third one, I can place 1 more hydrogen. Fourth one, I can place 1 hydrogen. Fifth one already has 2, so I can place 2 more bonds. And the last carbon, carbon number 6, has only 1 bond, so I can have 3 more bonds, 2 hydrogens. And there we are. So now we have a compound drawn, the structural diagram for 3-methyl 4-ethyl hexanoic acid. I hope you learned how to draw carboxylic acids. If you have further questions about carboxylic acids drawing, or if you would like me to draw a specific carboxylic acid, please put that information in the comments below. I will go through the comments, and if I find a request for a different compound that you would like me to draw, I will take the time and I will draw that compound and make a video about it as well. Have a great day and enjoy your day.